I'm gonna regret this our time.
Let's see what happens.
Oh.
First step, find a microwave.
Oh?
Okay, let's see if it works though. It has a light.
Hey!
Functional microwave? Check.
Okay, so then all we had to do was bring the microwave back to Karina's house and possibly set it on fire. Also, we needed to grab matches, we possibly were going to get grapes, and then other than that, I don't really know, we figured it out. A few days later, after we gathered our materials, we decided to set up at Karina's house, ready to go. And of course, we didn't forget our $20 microwave.
Safety is first, baby.
Now, before we get started, let me explain exactly what we're doing. On one of the first few days of class, Mr. Foster explained the Multiple Intelligences project and how open-ended it was. A few days into our first unit, and we were talking about the states of matter and, of course, plasma. One thing he was clear to mention was that plasma can be made in the lab, but that we would not be doing that in this class. Well, we decided to prove him wrong.
By the way, the cameraman is also not practicing any safety precautions.
Big brain, hadn't thought.
Match broke, okay.
Let's begin.
Okay, now everyone stay away.
Hopefully this is a There it goes!
That was pretty good, that was pretty good.
Wow, first try? Just kidding, that was actually our second. The first one was a dud, but now we're going to move on to showing some more fun clips before we explain what's going on.
Iconic. Who's your favorite Minecraft YouTuber? Oh, you know Nikki is epic.
He damn jumped.
Oh, not enough. Oh, maybe. Yes!
Briefly.
Kind of. Maybe. Yes!
Briefly.
Kind of. Mr. Foster, I'm so sorry you have to watch this.
But,
And 3 is about to go even better, hopefully.
okay, put it in there. Put it in there.
Oh boy.
So we learned it's not gonna really...
Oh, that scared me. Have the glass. And what's the other one?
You cut one open a little bit.
Yeah, we're definitely tossing that and pretending that never happened. Okay.
Basically, the glass kind of shattered a bit.
Here we decided to try the grape method.
Oh, you can hear him hissing.
They said we
They
gon'
don't like that
sizzle.
noise.
That's a... He's mostly just oozing out.
The grape method involves microwaving 2 grapes that are touching or cutting a grape slightly and microwaving that in the hopes that the ions in the surface of the grape skin are supposed to kind of charge and jump between the 2 layers, creating a spark of plasma. It didn't really work for us and we couldn't really figure out why it was even supposed to happen in the first place, so we went back to doing the match method.
Gooey. I don't like that. I mean, I don't know what else we expected.
It's pretty hot. Like, it's not crazy hot, but you can see it's kind of goop. Do you think the glove is doing so much?
Yes. It's absorbing the heat. It's saving our life.
Put it in there. Done? So we learned it's not gonna really do it.
Oh, it's still going. It's still going.
First of all, what is plasma? Plasma, like a gas, has no definite shape or volume, but plasma, unlike regular gas, is made up of ions and therefore has very strong electrostatic interactions. The sun and stars are almost entirely made of plasma, meaning it is actually the most common state of matter in the universe, even though we don't often see it here on Earth in our everyday life. But what exactly is happening in our microwave to make it so exciting? When we light a match, producing a flame, a combustion reaction occurs, and if the fire is hot enough and contains enough energy, a small amount of the gases can become ionized and become plasma. By doing this in a microwave, it is able to sustain the energy needed to form plasma. Basically, in the same way a normal microwave is able to heat up food, it was able to give energy to the atoms to allow them to become ionized. Now, why is the plasma yellow/orange or blue? It is all dependent on the elements present in the experiment. When you excite an atom, giving it energy in some form, for example, we use the superposition of the microwaves in a microwave, electrons can become excited, causing them to lose one or more of their electrons, becoming plasma. However, because this condition is not very stable, the electrons generally return to their original place not very long after. When they fall back into place, they emit their previously gained energy as photons, better known as light, explaining the glowing color of plasma. Therefore, the elements present and the amount of energy will determine the color of the plasma. Our plasma was orange/yellow, more of a traditional wood fire color, which is presumed to be due to potassium and some sodium in the match. The occasional blue tinge of the plasma would be from ionized gases in the air. Here you can see how from the match the plasma sparks up and takes on the shape of the glass containing it.
Not a good amount.
There we go. Oh, maybe. Yes!
Look at that. That's a good one.
Ooh.